Okay, we have a new model, and basically it's called the logistics model. Also, sometimes it's called the growth model. And we remember the numerator is our limit to growth. And in this case, it makes sense for this problem because we have 5,000 students, so no more than 5,000 students could be infected with the virus. So the information says one student returns from vacation, has a contagious flu virus, and the virus is spread with this model, and it is modeled in time in days, and they want to know basically certain things about this scenario. So how many students are infected after 5 days? So essentially I'm just going to plug in a t of 5. That's what this is saying. So I get y is equal to 5,000. Then I have 1 plus 4,999 e to the negative 0.8 times your 5, and all that would be your exponent. And if you do this in the calculator, be careful to either do it in separate steps or make sure all this is your denominator. So then the students that will be infected is approximately 54.019 students after 5 days. So that's one way we can use the model, is to solve for how many we have, whether it's infected students, whether it's bacteria, whatever we're modeling the growth for. And the second question is, how many days will the college have to cancel classes? At what point in time? So we're looking for time here. And we know that they will cancel after 40%, or at the point in time 40% are sick. So we want to solve this and say 2,000, because that's 40% of 5,000, is equal to 5,001 plus 4,999 e to the negative 0.8 t. And we're actually solving for t. So we do want to get t basically by itself, e to the negative 0.8 t by itself, so then we can take the natural log. So I'm basically going to think of like clearing out the denominator. And you'll get really fast at this. You'll just know these will cancel. On the left side, I'll end up with 1 plus 4,999 e to the negative 0.8 t is times 2,000 is equal to 5,000. So I'm just going to divide both sides by 2,000 now. So I have 5,000 over 2,000 on the right side. So let me kind of bring this over here and tidy it up. I have 1 plus 4,999 e to the negative 0.8 t is equal to 5,000 over 2,000, or 5 halves. I'm going to subtract this 1. So subtract 2 halves, and I'll kind of tidy that up in just a second. And then I'm going to divide by 4,999. So subtract, that's gone, then divide. So I end up with e to the negative 0.8 t is equal to all of this. So e to the negative 0.8 t is equal to, and 5 halves minus 2 halves is 3 halves. And all that is divided by 4,999. And now I'm going to take that ln of both sides, ln here, ln of all of this, so be careful with that on the right side. And then the power will come down front, and I end up with negative 0.8 t, and I'm just going to divide both sides by negative 0.8. So time will be ln, and then 3 halves is just 1.5. I'm just going to put it like that. So go and simplify it. And if you notice, I have not touched the calculator, and that's what I want you to do. I want you to set it all the way up and not waste any time trying to plug anything in the calculator and writing it down. I just want you to get all the way down in exact form, and then you can plug it in the calculator. So when you plug this in the calculator, just be careful, and you should be getting 10.139, and this will be days. So somewhere in the 10th day is when they're going to have to cancel classes. Now, what if we're asked to write the equation? Here we use the equation two different ways, but what if we're asked to write the equation? So let me show you. We're going to do a couple like that. We'll look at number 1 here. And I'm going to remember that my model is y is equal to m, which is my limit to growth, and I have 1 plus a times b to the x, and this is the model that I'm going to use. Initial value is just another way of saying I have a data point at 0, 10. Limit to growth is saying my numerator should be 40, and then it passes through another data point, 1, 20. So I'm going to start by plugging in 0 for my x, and that of course corresponds to a y of 10. So now, there's a little quick thing of obviously b to the 0 is just 1, so that's kind of just gone from the whole situation. So if I recognize from the prior problem, essentially I can switch the 10 with the 1 plus a. And I went through this in class kind of at length, but if you want me to help you with that, please come in, I'll help you with that. But it just speeds everything up if you just see that you can switch the numerator here with this denominator. It's just basically a principle of proportions. So I end up with 1 plus a is equal to 40 over 10, which of course is just 4. So a is going to be 4 minus 1, or 3. Now I use that and I go back and I pick the other data point. So I use this one first and I use this one second. So I go back and I say, well, I still have my 40 for my numerator, but the ending value is going to be 20 when x, which we know is going to be 1. And then I still have my a of 3. So I have everything in place, 1 plus a times b to the x. And now I only have one unknown, and I can solve for my b. So same type of thing, I'm just going to exchange these two. So 1 plus 3b is equal to 40 over 20, which is just 2. Subtract 1. So I end up with 3b is equal to 1, making b equal to 1/3. So my model is, still have the same 40 in my numerator, 1 plus 3, and then 1/3 to the x power there. So that's how you would do one like that. Okay, now I want to show you a graph as well, so you'll know that you really have the same information, and it's also good to kind of see what the graph is going to look like. So I have a data point at 0, 5. I have a data point at 2, 10. So I have the two data points that I need, and then I also know my limit is 20. So I'm going to start with my 0, 5 and set that up. So I have 5 is equal to my limit of 20, 1 plus a times b to the 0, of course, is just 1. And remember, I'm just going to exchange these two, and I end up with 1 plus a is equal to 20 over 5, which is 4. A is 3 again, just by chance. Now, so I have enough where I can go ahead and find b. So again, go to the next data point, 2, 10. So 10 is equal to, I still have my 20 for my growth, and then I have 1 plus 3 times b to the second. This is a little bit different. Just be careful with that. And again, I'm going to exchange, so I end up with 1 plus 3b to the second is equal to 20 divided by 10 is 2. Remember, I'm just exchanging these two like this. And then I subtract 1, so I end up with 3b squared is equal to 1. So 1/3 is what I end up with on the right side, but then I have to raise it to the 1/2 power. I have to square root it. So I do both sides to the 1/2, canceling the square there. So b is really 1/3 to the 1/2 power. So let me show you how we're going to write this. We're going to say our maximum growth is 20, 1 plus my a of 3, my b will be 1/3, and then I'm going to write it as 1/2 times x, but I'm just going to do x over 2. So that's what's going on here. And then this will be a transformation. It's actually going to be a horizontal stretch because you're affecting the x value here. So that is how you would write that out. So you need to do numbers 1 through 8. Of course, we did 1 and 5 already, but that should help you understand this concept, and we'll check that tomorrow.